Hello students, this is Preeti Sharma, your chemistry teacher. Today I'm going to tell you about balanced equation. What is balancing of equation? Before starting balancing of equation, we should know about chemical equation, which we have done yesterday. Chemical equation is just a skeleton equation in which reactants and products atoms are not balanced. It means on both the sides the atoms are not balanced. But in balancing equation, the equation in which atoms of various elements are in equal number on both the sides. It means the number of atoms on reactant sides as well as the number of atoms on product side must be equal. That equation is known as balanced equation. Let's take one example. 4 molecules of NH3 when reacts with 5 molecules of O2. It forms 4 molecules of NO plus 6 molecules of H2O. You can see students that on both the sides the number of atoms of each element is equal. We can just look at your screen. Here on left hand side we have 4 molecules of nitrogen. Again on right hand side also we have 4 molecules of nitrogen. On left hand side we have 12 molecules of hydrogen, and again right hand side we have 12 molecules of hydrogen. It means on both the sides the atoms of elements are equal. Similarly, we can see for oxygen. Here we have 10 molecules, 5 to the 10. 10 molecules of oxygen on left hand side. Again, we can see our product side. Here again we have 10 molecules of oxygen. How we have 10 molecules? 6 molecules are written with H2O and 4 molecules are written with, that 4 atoms are written with NO. So if we'll add them, it means we have total 10 molecules of oxygen. I think I must be clear. Now the question arises, why do we need to balance the chemical equation? What is the need to balance? Why can't we write the equation simply? So the answer is number one, to satisfy the law of conservation of mass. What is conservation of mass? The total mass of product obtained in a chemical reaction is always same as the total mass of reactant taking part in reaction. To satisfy the law of conservation of mass, we must balance, because according to the mass theory, that conservation of theory, the mass obtained in the product must be equal the reactant molecule mass. It means the number of molecules which is taking part during the reactant side, it must be equal to the product side. And secondly, according to Dalton atomic theory, the number of atoms of each kind should remain same before and after a reaction. That's why we need to balance a chemical equation to satisfy these both points. Just have one example. Steps to balance a reaction. Now, students, how can we do the balancing? The balancing can be done by hit and trial method. Those who are beginners, for beginners, how we can balance a reaction? Step 1, take an unbalanced equation. Suppose we have taken one unbalanced equation. NaOH, when reacts with H2SO4, it forms Na2SO4 plus H2O. This NaOH and H2SO4 are reactants, and we can see Na2SO4 plus H2O are products. Step 2. Draw boxes around all the chemical formulas. We can see the boxes around us. Now, step 3, make an element inventory. It means we have to make the table. Just see how we have made the table. In one side, I have written elements. In this equation, we have sodium, oxygen, hydrogen, and sulfur. And on both the sides, I have written left hand side and right hand side. On left hand side, we have counted the number of atoms, and again on right hand side, I have counted the number of atoms of each element. We can see that on left hand side, we have only one sodium atom, but on right hand side, we have two sodium atoms. Again, for the oxygen, on left hand side, I have 5 oxygen atoms, and on right hand side, again 5 oxygen atoms. On left hand side, we have 3 hydrogen atoms, and on right hand side, we have 2 hydrogen atoms. On left hand side, we have 1 sulfur atom, and again on right hand side, we have 1 sulfur atom. It means some of the atoms of elements are not balanced, but some are balanced. Now, what is the next step? Step 4. Write number in front of each of the boxes until the inventory of each element is same on the both sides. It means we have to multiply the number of atoms just before the boxes. We can see now, to balance the sodium atom, we have to multiply the sodium atom with 2 so that both the sides get equal. And we can see now the next element is oxygen. Previously, we had unequal number of oxygen atom on the both sides, but just to balance them, I have just multiplied the water molecules by 2 on right hand side to balance the oxygen atom. And again, hydrogen. Hydrogen on both the sides already get balanced when we'll do balancing of each element, and sulfur was already balanced before and after the reaction. So what is the last step? The last step will check that both the sides must be equal, and now the equation is balanced. We can see we have 2 molecules of sodium on left hand side, again 2 molecules of sodium on right hand side. We have 6 molecules of oxygen on left hand side, and again 6 molecule of oxygen on right hand side. How we can check that oxygen molecules are balanced? First, 2 oxygen atoms are present with NaOH, and 4 oxygen atoms are present with H2SO4. It means we have total 6 oxygen atoms. Similarly, we can check how we have balanced the oxygen atoms on right hand side. We can see that we have 4 oxygen atoms in Na2SO4 and 2 oxygen atoms with H2O. So total is 6. It means we have balanced left hand side as well as right hand side. Just have one more example to understand it. Suppose the question arises, write the balance equation for the reaction involving the combustion of methane with oxygen to form carbon dioxide and water. So first of all, how we'll do this question? Step 1. Write the equation in word form, because in earlier example, the equation is already given. The symbolic equation is given. But in this example, you have to make your equation in word form. The word form equation is methane plus oxygen. When reacts, it forms carbon dioxide and water. Step 2. Write the skeleton chemical equation. Indeed, it means you have to write the formulas. Methane formula is CH4, oxygen is O2, and carbon dioxide is CO2, and water is H2O. Now, what is the step 3? Please Understand carefully, selecting the elements which occur at the minimum number of places. Instead of boxes, we can do directly. We just see the atoms on the left hand side as well as on the right hand side. We have to consider each and every element individually. For example, my first element is carbon and my second element is hydrogen. So first of all, I'll balance the carbon atom. But we can see that in our equation, the carbon atom is already balanced. It means we'll look after into hydrogen atom. On left hand side, we have four hydrogen atom, and on right hand side, we have two hydrogen atom. So to balance both the hydrogen atom on both the sides, what we can do, we will multiply our water molecules on right hand side by 2. Why we are multiplying our water molecules on right hand side? Because we have to multiply on that side where the number of atoms are minimum. That's why we are multiplying by 2 on right hand side. Just see, after multiplying, what the equation is CH4 plus O2 gives you CO2 plus twice molecule of H2O. It means we have balanced our hydrogen atom. Now step 4, to balance the oxygen atom. Now the terms come for oxygen atoms because carbon atom is already balanced. We have balanced the hydrogen atom. Now the term comes for oxygen atom. There are two oxygen atoms on left hand side and four oxygen atoms on right hand side. So to balance them, multiply the oxygen atoms on left hand side by 2. We get this equation. Now we will check our equation. Equation is balanced. Just see once. On left hand side we have one carbon atom. On right hand side we have one carbon atom. On left hand side we have four hydrogen atoms. Again on right hand side we have four hydrogen atoms. Left hand side we have four oxygen atoms, and again on right hand side we have four oxygen atoms. It means we have checked the correctness of the equation, and now our equation is balance. Thank you, students. Stay blessed. God bless.